So, welcome to the course on peer-to-peer network. I am offering this course for the first time as a MOOC. This is lecture number 1, where I will be introducing you to the various basic things about peer-to-peer network, and as we go along we will explore more and more about this. For my introduction, I am Professor Y. Singh and I am in IIT Kanpur, and this is the website where actually you can find information about myself, and this is my Telegram ID over which you can communicate to me if you want. The reference material for this course will be available at the Telegram channel with this string t.me/p2p_mook. I will be posting all my lecture notes. In fact, all video recordings which will be made here will also be available there, and some of the material is available at brahaspati.nmeict.in, where I have pushed in the lecture notes or the study material which have been used in my courses, the variants of the same course which have been taught in IIT Kanpur for in regular semester for PG students. Now let us come to why we require this P2P network. We already have internet, we already have telephony network, we are able to communicate with each other, and still we talk about peer-to-peer networks. And what is this peer-to-peer network is actually? So for this we need to understand what is a conventional network, the internet which so called, or the telephony network, and what is lacking in them, and because of that gap we are trying to go to peer-to-peer systems. So if you look at the conventionally or what happens normally nowadays, we call it client server technology. There is always a server, okay, which you can all identify by their names. So for example, you go for checking your mail on Google, so you will always identify gmail.com as the name of that server. So this somehow on the internet will get converted to a other address of the server machine, and from your machine or your laptop or your desktop or your browser on your mobile phone, you will be connecting to this server. Okay. Now the program which in your browsers mostly will communicate with this www.gmail.com will be a browser, and this browser will be sending requests over the internet, which you can see here. Okay. So this is internet, this will go to the web server, which in turn will talk to an application which you can see here. This application is can be flat web pages or can be some logic which is dynamically generating web pages for you, and with the red path you will be returning all the way back to the browser, and that is how when you want to view an email, so a command goes all the way to the web server, and then a new page will come back which will show what is your email ID. We are slightly more sophisticated because we run in browser a small application which talks to web server and fetches the information and displays it to you continuously. Similarly, we can think of another application called mail. So we all have been sending emails. So the client which I use on my desktop or on my laptop is Thunderbird. You might be using a Gmail client in your Android mobile phone, or you might be using something else. Okay. So in that case these clients will normally talk to something called IMAP server, Internet Message Access Protocol, Mail Access Protocol, and SMTP, Simple Mail Transfer Protocol, SMTP servers. So when you want to send an email, your client will use this SMTP protocol. The protocol is a set of rules which have to be followed by the two endpoints or two sides across the network, so that they can understand each other's language. So there is a set of rules which have to be framed for communication. This is what we call protocol, and these are formally documented. So, for receiving the email to your client you use IMAP, you connect to IMAP server, for sending it you again give it to an SMTP server. So, but server is very sacrosanct, they have to be available 24/7, okay. They cannot go down, and they have to have a huge capacity so that they can serve large number of users who are connecting from their laptops or desktops or mobile phones, okay. And of course, in case of SMTP servers we even define zones. So, IIT Kanpur will have one SMTP server and one IMAP server, and we talk to IMAP SMTP server of other institutes for transacting the mails, and whenever this clients will talk to SMTP server they will do a authentication. So, that when you are sending a mail we have a record you logged in as which particular user when you have given send the mail through the SMTP server. So, this is used in case of if we need to investigate who was the original person who actually has submitted the mail. So, this is kind of a security system. Now, this actually means we will have machines in the net, and so these there will be many clients which will connect to the server, that is one of the key things here. So, there can be thousands of clients which can connect to server. Now, here you should think if Google is also running a mail server www.gmail.com on a browser, there will be billions of people trying to connect to Google at any point of time. A single server probably cannot handle this. So, they normally use not one but multiple servers, and different people will always connect to different servers. So, maybe everybody who is in UP area is connecting to one specific server, somebody else is connecting to some other specific server. They essentially do partitioning to support large number of users. And now, one of the problems with this server based thing is that owner of the server will have lot of private information of yours. So, Google as of now might be knowing about your phone number, they know about they will not be knowing about your password, because when you send a password they will immediately convert into a hash. I will talk about what the hash is as we go along the course. So, hash is basically in a layman's term for now is you take any string, you pass it through hashing function, it will give you a certain number of bits, and if you know these bits you can't get back what was the original information from which this was generated. But if you know the original information you can find out the hash. So, it is a one way transfer, one way mapping from an infinite set to a finite set. So, normally all passwords are being hashed, and this hash value is kept in a table. So, the owner of the server will not be able to find out what is your password, but if you give the password he can compute the hash and match the hash and make a guess that yes, password is correct. Yes, there is a finite possibility that more than one passwords may map to same hash value. So, but chances that this collision, this is what we call collision, chances this collision happens is extremely low. So, most of these devices work on that principle. That is one problem with the server based system. So, a lot of this private information being available, and if somehow a compromise happens on the server or the owner itself goes rogue actually, so then they will have lot of information about you. So, normally users would like to have the right over the information about them, they do not want anybody else to know. So, it should be the right of the user to tell who should know how much about him. So, that right to privacy is important. So, normally this will be handled as of now by regulation of the government, which will be applicable to the server owner. Of course, we do get into trouble if the servers are residing outside India, then Indian government cannot control the owner. So, normally we require because of this that servers of any internet service which is being provided in India, any kind of application, the servers have to be maintained within India, so that the information is not outside, and government of India can actually control or access that information on need basis. Okay. So, the law actually allows this. And now the second problem which happens is these servers need to be extremely powerful machines, and they need to have huge storage, and they need to have extremely high reliability. So, normally this is done by running multiple servers and they act like hot standby. Even if one server fails, the other machines automatically takes over. We have those kind of mechanisms to be built, and because you want high reliability, good air conditioning systems. So, so all these will essentially be set up in data centers. So, cost of running a data center will also be huge. So, this essentially entails lot of infrastructure cost if you are going to go with client server thing. But this was required in past because good computing was costly. So, people were actually having their end devices were low cost, low compute power, low storage kind of devices. So, anything which is costly was shared among large number of people, that is where the server concept actually came in. So, initially they used to be compute servers, so used to do telnet. Telnet is a program by which you can log in into a machine and run your programs there. So, that is how it started. It is a sharing of resources to reduce the per user cost. So, that was the idea why servers actually came into picture. They were shared resources, and of course, now this sharing leads to reduction of cost per unit of compute or per unit of per user. So, this lower cost was essentially the driving force behind having servers all across, and so now this become kind of a de facto thing. So, everybody has been talking about servers only and talking about data centers, and people will access services from there, but things have changed over time. So, this good business principle of sharing costly resource so that utilization become very high and which will reduce the cost has to change now. Technology has changed and cost of compute has gone down drastically. Okay. So, now even look at personal devices, what is the situation with them? They are more powerful than what they used to be there in past. So, even in fact some 25 years back, if you look at a supercomputer, now your mobile phone which is octa core running at more than 2 or 3 gigahertz, having 12 GB of RAM, probably that mobile phone is more powerful than that supercomputer. So, handheld mobile phones with 12 GB of RAM, 256 GB flash storage, 1 Gbps Wi-Fi, 2 gigahertz clock rate or even higher are kind of very common things now. So, with such a kind of powerful thing and they act as client, then you need servers of very high capacity, and of course, you will not be able to use these devices fully unless servers of extremely high capacities are actually being built, or alternately each server will be able to handle now less number of users. Okay. Now, we also have a drastic change, the storage cost has gone down. You can see 256 GB is a huge space, and maybe in time to come mobile phones with 1 terabyte kind of space flash storage will be viable. Okay. So, this actually means now lot of compute is available and resources are available at the user end. So, servers are probably has to go now. Another thing which has happened is capacity of networks has increased drastically because optical fiber has been inducted, and now you can easily think of 10 Gbps or higher links. In fact, IIT Kanpur has 2 10 Gbps links which we could not have imagined when I joined this profession here. And when you want to build up servers to cater to these devices, so either number of users per server has to go down, or server has to be also their capacity has to increase, their compute, their storage, their bandwidth everything has to go up. So, this will become more costly. So, now idea here actually comes that why we can't combine the compute of the user end devices, their storage, and because we have now very high bandwidth available even to the user, connect all this and network all this capacity together to build up the systems instead of using servers. So, we can we do away with the servers, that is a question, and certainly it should be feasible, and that is what the peer to peer networks actually talk about. Now, normally what kind of applications are existing on the internet, let us look at that. So, the networks which are or internet is basically being used for communicating the captured or generated information. You are doing Facebook, you are either getting information or you are generating information and pushing it to the network, and other people are accessing it. So, this is not over space, not, it is not immediate also, it is also over time. So you do it now today, somebody else get it tomorrow. So immediately only over space, if you want to do it, telephony is a good solution, it is a live thing. So alive as well as live as well as non-live kind of communications both are supported. You also store the information that actually implies, you store it for archival purpose, you store it for later on access, and once you start storing, you also can index the information, you can derive more information based on the indexing or processing. So all this functionality what has to go in the server actually. Now all this communication, all these capabilities which happens because of the network and servers have to be now, can this be done when I build up user machines being assembled together to build up a distributed serverless system essentially, or we call it peer to peer system. So now there are actually problems the moment I talk about this. So let us look at what specific problems we are going to get in a client server system, because we have to address each one of these issues when we think of designing a peer to peer system. So I am specifically mentioning those things. So here you can see in a client server thing, there are two nodes which are 1 and 2 here being put, they are being connected to through an internet, which is again I have shown, and they are connecting to server, and these servers need not be one, they can be multiple clusters of server, but for the user they are only being visible as a one single machine. Now these servers need to have a fixed IP address. So every machine on the internet for routing the packets, it is a packet switch system internet, sending a information to him we need IP address if we are following TCP IP network. So these are going to have a fixed IP address, that is one important thing. But while your mobile phone, when you are using it, so you change your location, its IP address keeps on changing dynamically all the time, because this IP address is being allocated through a server which is a small DSCP server in various zones of a telecom operator. Okay. So clients mostly are going to have dynamic addresses, while servers are mostly based on static addresses, that is a current way of handling the things, and these server addresses can be IPv4, can be IPv6 both, 32 and 128 bits both. Now when you change your location because of mobility, your IP address has to change so that the packets can be routed to you. So different zones will there, because we need routing aggregation, I do not need to maintain routing tables for every device, for a zone I will keep one routing table entry at other places. So all addresses have to be somehow related, so when you move into a zone your address has to change, and that is where dynamism of IP addresses do come for the clients, because clients are mobile, servers are not supposed to be mobile, they are static, they are at one place. Okay. So they can have fixed IP addresses. Maybe one option which you can have is, if the clients have to work like server, so they can actually tell about themselves to continuously to the mechanisms which are going to be identify where the server is. I will talk about that, but normally what each client does as of now is it will be depositing the information to server. You are doing it to Facebook when you are running Facebook client, you are retrieving the information from server, you are asking it to process some data. What we want to now make a change is that there are no servers, you want the information, you fetch it directly from the other clients, other users, you want to give the information, you give it to other users, okay, and you want to process, you actually yourself process it, or you ask some of your other client to process it. But the problem is other clients, they are mobile, their endpoint addresses will keep on changing, or IP addresses will keep on changing, they may not be on, because you turn off your mobile phone, you can turn off your laptop when you are not using it. So that reliability of servers is missing, okay, and the static nature of IP address is missing, and still we want to do the function. So let us see how it happens through indexing servers. Okay. So normally the idea here will be that if somehow we maintain something called indexing server, we need to at least maintain something like this, that is a naturally occurring way of solving this problem. So every user, every peer client, for example here I have shown all peer clients can talk to each one of them, I have not shown all the links. So, there are 7 of them, so it will be 7C2. Okay. So, 7 into 6 by 2. So, it will be 21 links which will be there among them, so that they are all connected to each one of them. So, it is a overlaid network, so they can over the internet can directly communicate to each other. So, that is a virtual link. Now, we need to also maintain a server. So, each one of them will publish in the indexing server what kind of resources it has and what is its IP address. So, when somebody wants to search for a resource, it goes to indexing server, and indexing server will search through the resource, will then find out who has this particular resource, what is its IP address and port number, and then you can directly make a connection and fetch the resource. So, indexing server is a central repository through which you can identify who has what resources. We even do it now. You want to, for example, find out something about want to learn about some content, for example, you want to find out how what is coronavirus. What you do, you normally go to www.google.com and put in coronavirus in the search engine, and as a consequence you will get a list of lot of websites which are mostly static websites, because they are fixed IP addresses assigned to them. This is not the user client machines, but it is a index. So, google.com basically maintains a index. So, it creates search index by crawling through all the static web pages all across the world, static and dynamic both kind of contents. Okay. And once you get this thing, you can fetch from that server. So, instead of client, you are fetching it from server, and these are mostly static addresses. When you want to build up this kind of index, you require dynamic addresses to be handled. And one very important thing, because nodes are acting as a server as well as client in a peer to peer system, this network should never get partitioned. Okay. So, there has to be, we create technically an overlay into this. This should I should be able to reach, I should be able to know everybody. Basically, if I know who are my neighbors, they know who are their neighbors. So, it is basically knowing about the information, it is not maintaining connections, it is reachability. So, reachability to every node in the peer network should be maintained. So, network should never get partitioned, so that one half of the network does not know even a single node from the other side, and these two cannot reach to each other. That should never happen. So, that requires a kind of a trick. I will explain how that is going to be done when we talk about peer to peer routing tables. Okay. So, now these all can maintain now this index, the centralized index which I talked about earlier. This will now have to be managed in a distributed fashion. Can this be done? So, not only this distributed fashion in which I am going to store all the index entries will allow me to maintain the entries, but also it will give me a method by which network will never get partition, that can also be guaranteed. Okay. This is what we call logarithmic partitioning. So, now this is what I was talking about, each client need to find out, figure out somehow that who has the resource. So, now what could be this resource? Let us talk about this resource. So, this can be a file. So, that is what you do with the web page, you are trying to search for coronavirus thing. So, who has published the files about coronavirus? So, you go to Google, search into the index, get the URLs and click on that and directly fetch the file from the other servers. There can be services also. For example, you want to make a telephone call to somebody. Okay. So, this what happens in SIP telephony, session initiation protocol. So, all modern day telephony is based on that. So, you normally every phone will get registered to the SIP server. So, SIP server maintains an index of which user ID is mapped to which IP address and port number as of now, and this keeps on changing every few minutes. So, as your IP address changes, your record will also keeps on changing. When you want to make a phone call, you go to SIP server, find out the IP address and port number of your destination to whom you want to call, fetch it, and then you set up a call through that SIP server. You can similar to IPTV streaming, it is a live thing, it is a service. So, service also can be searched and can be connected to. Okay. You want to do a compute, for example, you can go to this thing and find out a compute service where it is available, connect to that service and do the compute. So, resources can actually be files as well as services both. An important thing is endpoint identification. So, that is a crux, whether doing it through indexing server or through a distributed mechanism. And if it is going to be kind of a distributed system where these are all mobile clients which are acting as server, they need to tell every time the key with which they need to be searched. For example, I am providing a file on coronavirus, whenever my IP address changes I should tell indexing server ki update my address to this, and this is the key for which I am holding the document. So, key will be the keywords by which you search the document and you will end up in getting my address. Okay. So, key and endpoint address, that is basically is search key and what is the corresponding value of that key. So, this has to be updated by all the mobile clients, so that addresses can be changed. That has to be the one change which has to go. With the static addresses this is not that much of a problem, and normally is a Google which runs crawlers and searches the web to maintain the index. It was not the applications or the user end which was updating the index, but now situation is different with peer clients. So, we can actually have this dynamic index update. So, we have on a similar concept dynamic DNS. So, your name remains the same, but your name to IP address mapping has to change. So, as your client machines IP address keeps on changing, you keep on changing your DNS entry, but the entry which is maintained in the Google is based on your DNS name. So, they need not do it on Google. Google always keeps the resource with the domain name. So, it will tell coronavirus.iitk.ac.in will be the name. So, name to IP address mapping you can change in dynamic DNS, that is what can be used now. Lot of small businesses use this to maintain their websites. So, now there is one important thing in peer to peer systems user clients. In current day thing it is endpoints are server, and as I mentioned just now that they will always be identified by names, not by IP address. And there is also a reason why this has to be done, because people cannot remember IP addresses, names you can always remember. Okay. So, you know that you have to go to www server of IITK, you always say www.iitk.ac.in, you do not have to remember the IP address, and I can always keep on changing the IP address. Okay. And you connect to this browser will connect to the IP address on a well defined server port. So, these also have been identified. So, for web service it is port number 80 which is used, for secure web it is 443, for proxy cache it is 8080, there are many ports which have been defined, and only change now we are making is now resource providers will be the user machines. So, we have to also do away with this well known identified port numbers. So, port numbers can be dynamically changed, and we have to also take care of the index in a distributed fashion. So, as I told, Google can provide dynamic updates. So, user machines can update it dynamically, port number as well as IP address both, the content identifier and as well as the transport protocol both. Okay. We will just change this to a distributed system later on, this is centralized indexing. So, this way now anybody can connect to the user machine and then fetch the data, but here one of the problems is how you will be sure that the user machine is an authentic machine, is an authentic user. So, what he is telling that he is actually he is. So, there has to be a way to do it. On servers this is done in a certain specific fashion using basically security certificates, and the risk with this content with the user machines is that as IP addresses change periodically they need to be updated. So, but you have to verify this guy is genuine all the time even when IP address is changed, somebody else is not faking as that guy. So, security issue has to be handled. So, the problem which can happen is some rogue node can register its IP address and can provide incorrect content, how that will be taken care of. Okay. So, even the websites can be spoofed, but websites spoofing now has been more or less resolved by forcing the browsers to use HTTPS protocol, otherwise there is a warning which is being shown to you. Now, this S stands for secure HTTP. So, you can verify the site name whether it is a genuinely the owner of that site name is that machine or not can be done, this verification can be done. So, we need to understand public key cryptography for this. Okay. So, this we need to understand. So, let us move to that. So, what is this PKI? So, this is essentially means that we can generate a public key and private key, and good thing is that both have to be generated together. Okay. You can't generate one, you can't know public key and find out from their private key, or you can't know the private key and then find out public key, that is not feasible. So, both have to come out at the same time from the algorithm. One of the popular algorithm is RSA algorithm for doing this, okay. And there is now even a better variant, curve cryptography based system is also has come, by which also the similarly two keys can be generated. So, now one important thing is, if I have key 1, for example I take private key, I take this content and I use a hashing function, and it is basically keyed hashing. I can give key as an input, content as an input, there is a hash which gets computed. Hash is a fixed length string, okay. If I change my key, my hash will change. If I change my content, then also hash will change, okay. So, same content signed by different keys will lead to a different signed hash, okay. So, this mechanism actually can be used. Now, as I said that two keys have to be done together, and knowing one you can't find out the other, that is a key thing. Now, these key pair, one of them can be private, become private, other one can become public key, it does not matter how you do it, but both is like a pairs. And the algorithm actually came with Rivest, Shamir and Edelman from MIT actually, they gave this algorithm key pair generation. And the problem here is, you take two large prime numbers, make a product of them and you will get a number. Now, doing the reverse, if you know the large number, finding out the prime factors is a difficult problem actually, and that basically is the basis, that finding out two large prime factors of a large number is difficult. That is what is being used to essentially create this whole system. Now, this is the basic property, as I told that one key will be known as private key, and it should be only known to the legitimate user who actually owns the key, other key is public. So, the other public key will be known to everybody. So, this guy will tell my name is so and so, this is my public key, okay. So, this public key is anybody can keep it. Now, what you do is, if I want to publish any content, I will take the content, I will use my private key, okay, and then generate a hash, and this hash will be published along with the content. So, these two things will be put together and will be published to the users. Now, users will have the corresponding private key. So, there is a corresponding private key, corresponding public key, sorry, and this public key can be used to verify whether this hash was indeed generated by the corresponding private key and the content. So, if the hash match does not happen, then there is a tampering in the content, or the hash either must have been done during the transit. So, nobody can tamper. So, we can do tamper proofing of the content with this. So, that is a signature process, okay. Now, this is where I have shown it. If a content is tampered, you use your public key, you input, compute the hash, you also put in the hash, the verification will fail unless this public key corresponds to that private key and content is as it is intact. So, even a single byte, single bit is being modified, the verification is going to fail. This is what is a basic digital signature mechanism. We can also use the same thing for doing encryption. So, you take a content, you insert the public key, okay, and you run through encryption algorithm and you will get encrypted content, okay. This encrypted content, when received by the user, only he has the corresponding private key. He has to use this private key, this encrypted content, and he can get the decrypted content back. So, original content will be recovered. Now, you need to understand that nobody except the guy who holds the private key can decrypt this. So, this is pretty secure, it is asymmetric, public key is known to everybody. So, everybody can send encrypted information to one single guy. So, nobody else can read it, okay. So, these two things in combination actually can be used to build up our system. This HTTPS which I was talking about, verification system for a website, we have to use something similar in peer to peer system. So now one thing which you have to ask, we should actually ask, anybody who is logical will always ask, when I am doing signatures here, why I am not using a public key? So when I want to generate a hash, why not public key? Now if you can do it, anybody can generate the hash. So it does not make sense. If signatures are done with public key, they are useless, anybody can do that signatures. Signatures should only be doable by the owner, nobody else. So it has to be done through a private key, because he is the sole person knowing the private key. Okay. Similarly, doing encryption with a private key does not make sense, because anybody who holds the public key, which is known to everybody in the world, they can decrypt the information. So there is no use of doing that encryption if anybody can read it. Okay. So encryption is always done with public key, and signatures will always be done by private key. Other key will be always used for the reverse process. Okay. So normally the way it is done is that we have to create an infrastructure. So we will have something called trusted authorities, certification authorities, and their public keys will be well known to everybody. So if you look into your browser, you can go into settings, passwords and security. Inside this there will be trusted certificates. So I think every few months there is going to be a browser update or operating system update, and these certificates will get updated. So it is basically the trusted public keys on which you have a trust. So these are certification authorities. Okay. So these are distributed periodically, and these are used to check essentially if the other end is genuine or not genuine, and these are kept in a trust store. We call it trusted public keys, and we call it a trust store where the trusted information is kept. Now public key normally is given as a certificate. Okay, so it will have unique ID, email, mobile, Aadhaar, maybe other details. You can put your public key there. Okay, and this information now can be signed. Okay, and this signed hash can be generated by a certification authority. So if there can be another field here which will mention that who is the certification authority here. So this CA authority will use its private key to generate the signed hash. So now anybody who is going to look into this will look at the CA authority signed hash. It will then look into its own trusted store whether its CA authority exists there. Okay, and that CA authority certificate will be a public key which will be there in trusted store. It will use that public key to verify this signed hash, and once this signed hash has been verified, the guy is genuine. So this whole information is fine. The public key which is being mentioned is also fine. Okay. So public key which is stored in the certificate is used to verify if it is indeed signed by the owner of the corresponding private key. So we can actually have extra information if you wish in this certificate, which can be self signatures, which can become part of the certificate itself. So that depends on how you configure, but normally the self signatures are not required. So whenever you are going to generate public private key, you will be creating only this information, your unique ID, email ID, mobile number, everything, and your public key. This information you will be giving it to certification authority, which in turn will do one thing. It will verify each and every information provided by you. For example, your email ID by sending an OTP, your mobile number or maybe Aadhaar number through an OTP. Once that is being done, OTP, so this information is verified, you are the owner of that email ID. That will verify indeed that you actually have the private key or not for the public key which you have submitted. So it can generate a random number which then can be encrypted with this public key, can be sent back, and the client can decrypt it back and send it back through the public key by encrypting again through public key of the server, and then the certification authority will get the everything intact back. So the guy who submitted the request owns the private key, as well as he also is having access to the email ID or whatever other credentials which are there. So it will now digitally sign the certificate by its own private key and send the certificate back. Now this is very important. So servers also keep these certificates with them, Okay. So, there this is the generally the method used, but we can do it the other way around, where self signed certificate is further signed by a certification authority, but that will ensure that extra step of verifying whether the guy who has submitted the certificate generation request holds the private key or not, that step can be avoided, because that automatically gets added to the system. So, in our design, when because this whole thing which I am teaching is based on a development project which has been going on here in IIT Kanpur. I call it Brihaspati 4, which is a peer to peer system. Not only it will provide LMS, but other facilities also. So, we have already built a lot of part, it is open source project available on GitHub. So, I am basically teaching from there. So, we have done the design of the certificate in slightly different fashion, but in real life it is done in a different fashion, but this is still flexible. So, this is what I was talking about. If it is a self signed certificate, only owner could have created it. So, you do not need to do the verification of that, and when CA signs it, it means this was a genuine guy, email and everything has been verified by CA authority, and CA's public key would have been there in trusted store of all the clients, so they can accept it. So, normally this is the format which we have been designed for Brihaspati 4, but this hash, this particular part of the hash will only not be there if I am going to use the conventional structure, but in our structure we have actually kept it. So, just to actually avoid one more step. Okay. So, this is how the certificate will actually look like. So, we are now able to verify the ownership of this email ID, we are able to verify whether this corresponding private key of this public key is available with the user or not, and then this hash and this public key CA thing is available in trust store of others. So, they can always now have faith on this if the public key of CA which they have in their trusted store, through which they can verify this and figure out the hash. Okay. So, once they figure out the hash is justified, is verified, then this all is genuine. So, then they can actually figure out, talk to the SSL, essentially a small mechanism by which they can figure out whether this is a genuineness of the other end can be found. So, let me go through it and you will appreciate this one. So, now this comes to the S part. So, how this certificate will be used to verify the server end when you do HTTPS. Now, S stands for secure socket layer, SSL, and this is used for verifying the ownership of the domain name, and then you also use it for creating a secure channel to the servers. So, S is not only used for verifying the identity of the server, but also to create a secure channel all the way to the server. So, for example, www.google.com will have a private key corresponding to the certificate given to the domain owner. Okay. So, domain owner is again Google, and this certificate must have been signed by CA, certification authority, whose public key must be there in your trust store in your browser. Okay. So, the process will go something like this. This is a symmetric one. So, when your browser, which is A here I call it, is basically the principle of SSL, it is not exactly the SSL or secure socket layer. So, A will talk to server, it will request for the certificate. So, server will return the whole certificate intact, and certificate A will verify if the certificate is indeed signed by a trusted CA, and it will give warning to user if it finds out it is not signed by a trusted CA or it has been revoked. There is a revocation mechanism also. So, and if it is yes verified, the certificate is fine. Now, it has to, the user A has to find out if server actually owns the corresponding private key or not. So, just presenting, because anybody can present you the certificate, but important thing is the corresponding private key is being held by the server or not. So, for that A will generate a random number, I call it SR, it will be encrypted with the public key. Now, remember, if the server holds the private key, then only it can decrypt back the SR, otherwise it can't. Okay. So, this random number is going to be sent, SR will be sent after encryption. Only if the private key is available here, SR can be decrypted, otherwise it can't be. Okay. So, once server is genuine, then only the step will move ahead, otherwise it won't. it will generate another random number called dr, it will encrypt with the SR and it will send it back. Now SR is not being sent in this reverse path, okay, in this path it is not being sent. So this way SR is only used for encryption purpose, dr is being sent. So once the dr comes back, it will decrypt with SR and will generate a new session key SR-dr. Now both sides I need to generate random number, so that even if you are using same random number, other guy may not be using the same random number and you will have a different session key. So you cannot listen to the earlier communication, cannot guess the new session keys which will be generated, is for that purpose. So session key will be computed here, same will be done by the server, and they will now do a secure communication over this using this session key, okay. So not only you have verified the server, okay, you have also now created a secure session, but note here the A is not being verified by server, A can be anybody, A has not presented certificate, A has not been challenged to prove that he holds a corresponding, A has not even may not even be having the certificate. That is what happens when you are actually using your browser to access gmail.com. Now what server can do is, it can actually use either OTP or it can use a login password mechanism to verify you. So you do not have to own a certificate because of that, because when you have to own a certificate, you have to generate a public private key pair, send all your information to somebody as CA authority who will charge some money, who will verify all your credentials, then will issue you a certificate which may be valid for a year, okay. So that all hassles have been taken care of for the common man. So we can actually use this same SSL in a slightly modified way for verifying each other, not only server. So that way that problem that IP addresses of the users will keep on changing, but their user ID, say email ID remains the same. So still I should be able to verify the other guy even when IP address is changing, there is nothing like HTTPS there. So but we can use this same certificate can be used for doing verification, okay. So for peer to peer authentication we will be using user identity certificate, not the domain name certificate, while for server authentication it was domain name certificate which were there. So this is the process where two users or two peer clients will do mutual authentication using this. So CA will be the certificate of A signed by a certification authority. So when A and B would like to talk, A will send a certificate CA to B, B will look into trusted store, find out the CA's public key, will verify the certificate. Once it is verified, is verified perfect, it will send back its own certificate CB to A. A will also do the same process, it will look into trust store, find out the public key of the certification authority, from there it will check whether the hash is correct or not for the certificate. If it is, indeed it was issued by CA, so CB is correct. Once these two are correct, then they can start the mutual authentication process. So what they have to do is, they have to basically verify whether the other side does hold the corresponding private key for the public key which is present in the certificate. So that is a test which has to be conducted. So what A will do is, it will generate a random number RA, it will encrypt that random number with public key of B and will send it to the RA, send it to B. B should be able to decrypt this RA if it holds the private key for this corresponding to this public key. Once it is done, it knows what is RB, what is RA, it will now generate another random number called RB. Okay, this is like a nonce is a randomized component so that the things do not repeat. So RB is going to be again sent, RA and RB concatenated will be sent through public key after encrypting through the public key of A, node A, and this will be sent back here. So if RA and RB both will be, you will be able to decrypt back. Okay, if RA is being recovered correctly which has been sent, so this you have verified this guy was the original genuine guy, and you have sent back RB available. So because of correct RA, B is authenticated, RB has to be sent back with the public key of B, B will be recovered. So B is also being genuinely received, correctly received RB. So B has authenticated A. Now they both A and B will now use RA and RB and generate a session key. B will also do the same algorithm, so there should be same session key. Now they can actually talk in a secure fashion with each other. they both have mutually authenticated and they both actually have created a secure session. Now there is no domain name in the certificate, now it is a email ID or a mobile phone number for between two peer clients, and though that is good enough for mutual authentication. So IP address is only for sending of the packets, it is no more used for authentication, domain name is not required, and this is a basic method of mutual authentication between two peer clients. So for this lecture I have talked about certificates ultimately for mutual authentication, and the unique ID which have to be mentioned, because each peer client will be identified by that, as I mentioned, can be any one of these four identities for our design. Depending on what you are implementing, you can actually make the changes. For Brihaspati 4 project we actually have done these 4 entities. So in fact now Skype for example is using your email ID for doing this verification, Telegram is using your mobile number, WhatsApp is using your mobile number, Telegram actually is using your there is a Telegram ID. Authentication is done through mobile phone, but they also allow you to generate your unique ID. Ntox is using a 256 bit I think string, random string, and you can give any pseudonym there. There is no IP address anything. Ntox is also one of the beautiful peer to peer system for messaging, and you remain anonymous there. So with that I end this lecture, and we will explore more about peer to peer systems in the next lecture.